One mechanical engineering, GATE 2021 aerospace engineering mechanical vibration questions. Okay, so there are total 4 questions. There are 4 questions total. Okay, so total 4 questions are there, guys. Just a moment, my notations. Yes. Yeah. So total 4 questions are there, guys. Okay. I think someone want to enter. Okay. So out of 4 questions, there are 2 questions for 1 mark. Okay. And there are 2 questions for 2 marks. Okay. Now, what happened in this 2021 GATE Aerospace? Uh, this particularly vibration part, there are 2 questions. One question where some data mismatch is there, okay, and in one question, there one exemption was not mentioned. So we'll discuss that also, and then there is a questions from 2 degree, okay. So 2D problem, which was MCQ, sorry, not MCQ, MSQ, multiple select question. So that we'll be discussing. Okay, so quickly we'll finish this, and you guys can share me feedback. And if any doubt, you guys can ask me. Okay. So the first question is what? A single degree of freedom spring mass damper system is designed to ensure that the system returns to its original undisturbed position in minimum possible time without overshooting. If the mass of the system is 10 kg, spring stiffness is 17,400 Newton per meter, and the natural frequency is 13.2 radian per second. The coefficient of damping of the system in Newton second per meter. So guys, in this question, if you look here, they have not specifically mentioned which kind of damping, critical, underdamped, overdamped. So can anyone tell me on what basis I can decide? Can anyone tell on what basis I can decide this is the overshooting? So they have told without overshooting. Without overshooting means what? It will be non-oscillatory motion. So without overshooting means non-oscillatory motion, and non-oscillatory motion can have either for critical damping or for over damping. But they have told here this system returns to undisturbed position in minimum possible time. So minimum possible time is always corresponding to critical damping. Okay, it is always corresponding to, guys, critical. Okay, critical damping. So it is corresponding to critical damping, because more the damping, more will be sluggish response. Means if you put more damping if you put, means if you make over damp, system will take more time. Okay, system will take more time. Okay, so that means your response will be sluggish. Okay, so so on this basis we can decide your system is critically damped. Now we know for critically damped system, what we know, C by Cc is equal to 1. So what will be C? It is equal to Cc, and it is either 2m omega n, or it can be also written under root km. Now what happened in this question? If you use this expression, you will get one answer. If you use this expression, you will get another answer due to data mismatch. Okay, so due to data mismatch, your answer will not be consistent if you use these two expression. Now this is derived from here only, because we know it is like what, 2m, what is the omega n? It is under root k by m, so you get under root km. So guys, quickly, here given is what, if you see, given mass is given as 10 kg, and k is given as how much? 17,400, and omega n is given as 13.2. Okay, yeah, 2 is there. Yeah, so it is 2m omega n, or 2 under root km. Sorry, I was missing here 2. And what is you are saying, Pushkin, radian per second? Yeah. So guys, what is the answer? Quickly you do, so we can move to, yeah. Yeah, unit you can write. It is 13.2 radian per second, and it is what? Newton per meter. So if you use the first expression, what is the answer? And if you use the second expression, what is the answer? So from first expression, 834, Kavi? Okay. Now tell me from second expression, what is the answer? Yes. So what happened in final key? They gave both the answer. Okay. They gave a range for both the answers. Okay. Now so these answers got correct only for those who have attempted. Okay. Either they gave answer 834, or either they gave answer 264. Then only they got my answer. If they have not attempted, by seeing this kind of mismatch or whatever the reason, they have not got marks. Because earlier days, sometimes people say if the questions or any mistake is there in question, they will give marks to everyone, but that didn't happen. Okay, so this is from this question, this is what the conclusion. Okay, now move to next question quickly. What is given? Two cantilever beam 1 and beam 2 are made of same homogeneous material and have identical cross section. Beam 1 has length L and beam 2 has length 2L. Ratio of first natural frequency of beam 1 to beam 2 is. So I think it's a simple question, and similar question was asked in previous years also. So here you know, for a cantilever beam, my first natural frequency omega n is always proportional to what? It is pi square by L square under root EI by rho A. Now since the material is same, cross section is same. Okay, so your omega n, only what is changing? Length. So omega n is directly proportional to 1 by L square. So what is the arcs? Omega n1 upon omega n2 will be what? L2 by L1 whole square. So what is the L2? It is 2L by L. So it is 4. Yeah, what is the doubt, Pushkin? Yeah, what is your doubt, Pushkin? Quickly. See, that's what I have told now. In the previous question, uh, they have mentioned minimum possible time. So minimum possible time is only for critical damping. If you put more damping, your response will be more sluggish. I have given this statement in IGC notes. You can check. Okay. So if your damping is more than critical damping, it will take more time to return to original position. Okay. So it is already written clearly in that statement. More the damping, more sluggish is the response. And I think we have solved some questions also in classes. In gate mechanical, those questions has been asked. I will share. There it is already mentioned in which case we will have minimum possible time. Class students, do you remember? I think one or two questions we have done. Anyway, I will share those questions in group. Okay, fine. So you should go back and look into your class notes, Mr. Pushkin. Okay, now these questions. Yeah, we have solved some questions, which is directly it was not written critical damping, but with language we can understand that is critical damping. Yeah. Now this question. Now in this question, what happened in GATE, guys? They gave one answer, but they didn't mention any assumption here. I will tell you when we solve this question what assumption has to be there. Okay. So now I solve all the questions only using one method, Newton's method or Newton's method. Okay, I don't use in vibration energy method to solve any questions. Class students, you guys will be knowing. So these questions also I will be solving using Newton's method. So suppose at any point of time my system is oscillating about this point and it is in this position. So suppose this angle is theta. You guys can read first this question. What is given? A rigid massless rod pinned at one end has a mass m attached to its other end. The rod is supported by a linear spring of stiffness k as shown in the figure. So you can see here this mass. Now when this is in oscillating position with the displacement theta, rotational displacement, so this will be the position of mass. Now you can see here this length is total L, okay, and this is H. Now what happens when this is oscillating in this direction? Inertia will be in opposite direction, guys. Inertia is in opposite direction, and when it is oscillating downward, there will be spring force which will be opposing this motion, and it will be what here? It is K into L by 2. Now this spring force will also create a moment about this oscillating point, okay, which will be also in the same direction of inertia. And what is the inertia? We all know I inertia is I theta double dot. Now this KL by 2 into this momentum L by 2 will give me restoring moment, which will be K L by 2 square. Now what happened? If you see this mass will have two components since it's acting like downward, right? So you can see parallel to this is this. So this angle is theta. Okay. So what will happen? This angle will be theta. Now this is mg. So there is one component along this, which is what? Mg cos theta. and there is a perpendicular component along this direction. It is what? Mg sine theta. Now what happens? This mg sine theta will have a moment arm. Length will be h. How this moment arm you can see? So if you take this is the moment arm h. Now what happened? This mg sine theta is in this direction, so this will give a moment about this point of oscillation in opposite direction to earlier moments. So what that moment will be? It will be mg sine theta into h. Okay, it is mg sine theta into h. Now guys, look here. Other than this, there is no other force. If you talk about this mg cos theta, what happens about mg cos theta? This mg cos theta, if theta is small, it is mg, and it will be balanced by your static equilibrium. So we will not consider it in equilibrium. So I have three moments, which are what? I theta double dot plus k L by 2 square plus this mg, not plus, there will be minus sign. Why minus? Because it is in opposite direction. Mg, and if theta is small, so sine theta will be theta into h is equal to 0. And I think here it is theta. I was missing. So because spring force is what? It is not KL by, KL by 2. It is KL by 2 into theta. Sorry guys, I was missing this. Slide is not visible. Okay. So guys, again, here theta is multiplied. Okay. Now if you see here, what will be natural frequency? My natural frequency omega n will be what? In this case, if you see, it is KL by 2 square minus mgh, okay, upon I. Now what is the I? If you take I about this point, what it will be? It will be this mass into perpendicular distance. So this is what your perpendicular distance. Okay, so it is m L square plus h square. Okay, because this is what your uh, distance, okay, square. What I can say, it is under root of L square plus h square whole square. Okay, so you can say inertia is what? M into L square plus h square. Now substitute here in this formula. What happened? If you see answers, M L square plus h square, guys. Now here look, in given answer, none of these option is available. In given answer, none of this option is available. So what we have to do? Can anyone tell what we have to do? We have to neglect gravity. Everyone, is it clear? To get the answer among given options, they have not mentioned, but if you see earlier previous years questions, there a similar question is there in gate mechanical, and we have done in class also. They have clearly mentioned in the gate question paper, neglect gravity. So if you neglect this, your answer will be what? Your omega n will be coming as under root k L square by 4m L square plus H square. So which is the correct answer, guys? And again, they what asked? They asked Fn. They didn't ask omega n. So they ask Fn means frequency in hertz. So you can say your Fn is equal to 1 upon 2 pi under root KL square upon 4m L square plus H square. Now here one more thing. This spring force how have come? You can see what will be this deflection. It will be L by 2 into theta. So L by 2 into theta into K is what? My spring force. Okay. So the answer, I think correct answer among these options seems to be what, guys? What is the correct answer among these options? A is the correct answer. Okay, I think not many people have done this problem correctly. Okay, because few of them may not find the I correctly, and some of them may not neglect this gravity. So they will see, like something. Some people even argued this question can be said like the data is insufficient, but they didn't consider. So A is the correct answer. Now come to the last question, which is like still not solved by many people. Okay, or many people finding the issue in this question. It's a very simple question. You guys can solve this question quickly. So on how you guys can solve this question quickly, I will give you the hint. So read this question. A 2 degree of freedom spring mass system undergoing free vibration with generalized coordinates x1 and x2 has natural frequencies omega 1 and omega 2 this, and they given the corresponding modes phi 1 and phi 2 is given. If the system is disturbed with certain deflection and zero initial velocities, then which of the following statement is true? Okay, they asked. Now guys, look here in this question. First, whatever this omega 1 is given, we are not going to use anywhere. So just write this omega 1 value. It is 233.9 radian per second. What is omega 2 is given? It is given as omega 2 is given as 324.5 radian per second. Okay, now what is important to me? The first mode shape phi 1. So what is the phi 1? It I can write it as a x1 by x2, and it is for first natural frequency, corresponding to first natural frequency. So it is 1 upon minus 3.16. What is the phi 2? It is corresponding to second mode, or you can say corresponding to second natural frequency. So it is again x1 by x2. It is 2, and it is given how much? 1 upon 3.16. Now guys, if you know the solution for these condition, if you have zero initial velocity, the solution for two-dimensional free vibration is given by what? If you write your x1, so your x1 will be what? Your x1, you can say 1 cos of omega n1 t plus it is x2, sorry, not x2, it is x1 corresponding to second mode. corresponding to second mode cos of omega n to t. What is the solution for this second coordinate x2? So it is x1, it is x2 corresponding to first natural frequency cos of omega n1 t plus it is x2 corresponding to 2 cos of omega n2 t. Now guys, if you substitute, see these solution can be used in all previous years question paper. Like in all previous years question, if you also look, every time for two-dimensional problem, for 2 degree of freedom system, they gave initial velocity 0. When your initial velocity is 0, your phase angles will be 90 degree. So always your solution will be given by these two equations. Okay, so I should know these two equations. I should also know further what, if you substitute time equal to 0, t equal to 0, so what you get, you'll get x1. So what is the x1? It is initial displacement of mass m1. So it will become what? If you substitute time equal to 0, it will become x1 1 plus x2 1. Okay, not sorry, it is x1 1 plus x1 corresponding to 2. Okay, now what will be x2? It is initial displacement of mass m2. So what it is? It is x2 corresponding to first natural frequency, then x2 corresponding to second natural frequency. So guys, always in 2 degrees of freedom, what all you have to remember? You have to remember these equations also. So what is this equation? This equation says your initial displacement of mass m1 is always equal to what? x11 plus x12, and same way x21 plus x22. What is the x11? It is the amplitude corresponding to first natural frequency. This is the amplitude corresponding to second natural frequency. Okay, so these equations. So now what these equal to, guys? I can say this is further equal to what? It is x1 1 plus x2 1, or I will write in next page, guys. I'll write here. So I can say, what is my phi 1? My phi 1 is what? x1 1 by x2 1. What is your phi 2? So phi 2 is what? It is x1 2 upon x2 2. Okay, so guys, remember these two as well as these two to solve any question of 2 degrees of freedom. Okay, and I think 3-4 questions are there in previous year's paper other than this 2021 paper. Now to solve this question, what we will do, we will go option by option. So look into option 1. What is given? An initial deflection of mass m1 is how much? 6.32, and for mass m2 it is minus 3.16. And what it is mentioned, the system vibrate only in second natural frequency. So system vibrate only in second natural frequency means what? If it vibrate only in second natural frequency, guys, this will be 0, this will be 0. Okay, so that means what? This term is 0, this term is 0. So using these equations, if you guys see case 1, what happened? Your x1, your x1 is 0. So in this equation, this is 0. So I will write this equation again. So what is my equation? X1 1 plus x1 2. And what is the initial displacement they gave? They gave 6.32. So you write it as 6.32. But the system vibrate only in second mode. So this is 0. Same way, what this? So what is my second? It is x2 1 plus x2 2. And how much? It is minus 3.16. So write it minus 3.16. Now this is 0. Now guys, you know x1 2 and x2 2, and these values you know. So if you write the ratio x1 2 upon x2 2, from here how much it comes? 6.32 upon minus 3.16. Can you guys tell me what ratio it will come? I think it will come minus 2, right? Minus 2 by 1. But if you see problem, what should be this ratio? This should be 5 to should be 1 upon 3.6. It should be clear now. Is this clear, guys? So A cannot be correct. My first second mode should be what? 1 upon 3.16. Everyone, is it clear? Anyone has any doubt in this? So what we have to do, from every option we have to find our modes phi1 and phi2. Those should be satisfied. Everyone, is it clear? Yes or no? Okay, I believe it is clear. If it is not, you guys can ask doubts. So this first option is wrong. It cannot be the answer. Okay, so now let's see case 2. Okay, so in case 2, what is happening? In case 2, if you read what is given, an initial displacement for mass 1 is 2 centimeter, and for mass 2 it is minus 6.32, and they mention this will make a system to oscillate with first natural frequency. It oscillate only with first natural frequency means what? This will be 0, this will be 0. So if you write equations, what you get? X1 corresponding to 1 plus x1 2, it is given as 2. I think, yes, it is how much? 2. And then x2 1 plus x2 2, it is given as how much? Initial displacement minus 6.32. Now system vibrate only in first natural frequency. So this is 0, this is 0. Then only it can happen. Now if you find the ratio phi1, so what is the phi1? It is x1 dash upon x1 1 upon x2 1. So it will come 2 upon minus 6.32. So that is nothing but minus 1 upon 3.16. Is it correct or not? B is correct, right? Because we can see my first mode is what? 1 minus 3.16. So B is correct. Now I will not check C initially. Why? Because it's a combined mode. It's a combined mode. I will check it, but first I will not check. First, what I will see, D option. Why I see D option? Because they mention an initial displacement 1 centimeter and minus 6.32 centimeter, and the system oscillate only with first natural frequency. So what is the difference between B and D? The only difference is these initial condition. But the system vibrate in first natural frequency only. So if you find the ratio for case 3, your x1 1 upon x2 1, it is how much? It is 1 by minus 6.32. Am I correct? Yeah. So is it correct? This is wrong. It should be like B, then only that is first mode. So D cannot be the answer. Okay, D cannot be the answer. Now gate people have given C is also correct, and I am also saying C is a correct. Now how we can understand? So to understand this, you can see when there is a initial deflection, this x1 is 2 centimeter and x2 is minus 2 centimeter, and they mention the system vibrate in the combined mode. So combined mode means what? This mode where you can see omega n1 is also there and omega n2 is also there. So if you take case 4, in case 4, what will happen? You will have 4 equations and 4 unknown. So what is those 4 equation, guys? So first, my this equation, what? X1 1 plus X1 2 is how much? Initial displacement is given as 2 centimeter for mass m1, and for mass m2, what is the initial displacement? Minus 2 centimeter. So you can write x2 x2 1 plus x2 2 is minus 2. So I have these two equation. Another two equation is what? I already know x1 1 upon x2 1 is how much? 1 upon minus 3.16, and I also know x1 2 upon x2 2, it is 3.16. Now guys, I have 4 unknown, 4 equations. So I can find from this I can find every value x1 dash, not dash, x1 1, x2 1, then x1 2, and then x2 2. Okay, I can find all value and all will be non-zero. Okay, how I can find? See guys, from this equation I can write this x2 1. See, x2 1 in terms of x1 1. Okay, then I can write from this equation what, guys? So in this equation you can write x2 2 in terms of 1 upon 3.16 x1 2. Now what you guys can do, you can substitute this equation and this in second equation. Then we can find the values of x1 dash and x1 1 and then x1 2. Is it clear, guys? Means simultaneously solve and find the values. You will get non-zero values. So that means what? That means your system vibrate in linear combinations with first and second natural frequency. It's a combined mode. Now they didn't ask exactly what will be the equation. They just ask, is this correct or not? So finally, what we can say from here, it depends on the initial condition. Your system vibrates in with first natural frequency or second natural frequency or with combined mode. Clear? Is this point clear what I am saying? Your system vibrates with a combined mode or first natural frequency or second natural frequency. It depends on the initial condition. So if you go through Grover, that example given in Grover book, you will clearly understand. They have given 4 cases. They have given 4 cases corresponding to first mode, second mode, and 2 cases were combined mode. That's why I have mentioned in group, refer Grover that example. You guys want to show me? I will just show that example also. Now is it clear? No, previous years not a similar question. This to this extent, first time only they asked. Earlier also questions are there from 2 degree. Those questions also you guys can solve using these 3 equations. What those 3 equations? Like these set of equations, and then these, and also if you know the what is this combined mode, first mode alone or second mode alone. Any doubt, guys? So C is the correct answer. Why C is the correct answer, guys? Again, I am emphasizing your all these amplitudes will be non-zero. So your mode is combined mode. Any doubt, guys? Any doubt? Mr. Kavi, now is it clear? So initially it was your doubt. And today who has shared this doubt and I solved, I will take up. That person is joined or not, I'm not sure. Okay. So, okay. Yeah. Fine. So if in doubt, then I will clarify. Otherwise, what I will do, uh, I will share that question, which is from what I say. Let me share those questions. 2 degree, right? So 2 degree. If I find. Not this one. Degree. Okay. Yeah. So this is a Grover example, and you can see there are 4 cases. Okay. So what is the case? One, both masses are displaced 1/2 centimeter. 1/2 centimeter downward. Okay, and released simultaneously. Then case 2, both the masses are displaced 1/2 centimeter but in opposite direction simultaneously. Okay, and then case 3, both the masses are displaced with a different magnitude, and same way case 4. Now in this problem, if you see in this question, the first task was to find natural frequencies, but in your gate exam already they gave natural frequencies. Okay, so that task is not there. So you can see here in this, first they found natural frequencies, they got these are natural frequency, and from these natural frequency we can find the modes also, and your gate problem they gave modes also, so that is also not required to find. Now you know here modes are given, so using these modes and other two equation which I have already told, these two equations. Okay, I think here, sorry, here. So these two equations and modes we can find these amplitudes. So from here what we found, amplitude, when we found this vibrate only in first mode. Why in first mode? Because here if you see, your x1 2, a double dash means 2 guys, here double dash means 2. So what happening here, x1 2 is equal to x2 2 and it is coming 0. So that means your system you can see only vibrate in first mode. Okay, same way when we use the case B, when they are displaced in opposite direction, what will happen, your x1 1 is equal to x1, uh, yeah, x1 1 will be equal to x2 1 and it will be 0. So your system vibrate only in second mode. In case 3 what happened, in case 3 what happened, if you use these 4 you will get all non-zeros. You can see all are non-zero, so you can see your system vibrate in combined mode. Now case D also same, if you use these 4 equations, okay, your system vibrate in combined mode. Now only in Grover what happened, I have used my notation like this, it is what, x1 by x2 I have used first, so instead of this first they are writing as dash, and I have written this x1 by x2 as a 2, they are writing it as a double dash. Okay, so double dash means corresponding to second natural frequency. One may single dash means corresponding to first natural frequency. So you can see it's exactly Gary questions asked in the reverse way. Okay. So fine, guys. Any doubt in this? Any doubt, guys? Kavi, any doubt? Somaya, Abhishek, Akash, Bhavesh, Ravindra, any doubt in this? I think Ravindra, you are July batch guy, right? No, I think I'm not sure. I have solved in July batch this clear. Jishan, is there any doubt? Okay. So if you remember these 3 4 equation from 2 degree, you can solve previous other questions also. Now one proposal, what I thought, uh, we those who are DLP student, I can make every day like 1 hour, so we can solve 1 by 1 year question paper. You guys can reply in chat box if you want. Every day we can meet in night till 10th, and we can solve uh, previous year's question paper 1 by 1. Yeah. Yeah, ratio it can be reverse way also, but you can make it x1 by x2. It can be given as x2 by x1, but in gate always it is given as x1 by x2 only. Because mode 1 means the first amplitude upon second amplitude, it will, like for mass 1 upon mass 2. It will be written as like that. It will be written like that, Akash. So guys, can we have session like till 10th? So